3 days ago, something happened that the American tech industry has been dreading for years. China just took the #1 spot on the global supercomputer rankings, not with a machine crammed full of Nvidia chips, not with AMD processors, not with a single piece of foreign hardware anywhere inside it. China's new supercomputer called LineShine just posted to 0.198 exaflops on the official benchmark that pushed America's best machine, Capitan, into second place by more than 20%. And here is what makes this genuinely historic. LineShine is the first machine in the history of supercomputing to cross to exaflops using only CPUs, no GPUs, no accelerators, just processors China designed and built entirely by itself using zero components that the United States controls. The machine that was supposed to be impossible just became the most powerful supercomputer on Earth. And the strategy behind it, this is the part that should make every American tech policymaker extremely uncomfortable, is now fully proven. Not theoretical, not claimed, verified, benchmarked, and sitting at #1 on a list that has existed for 30 years. I want to explain exactly how China pulled this off, why the common explanation you are hearing is incomplete, what LineShine actually cannot do that America's machines still do better, and what this moment tells us about where the next 5 years of the computing race are heading. But before we get into any of that, if you watch this video to the end, you will have a genuinely complete picture of this story. Not the headline version, the full version, and I want to know what you think. Right now, before you hear any of the analysis, rope a comment below. Just one word. Is China's achievement here a genuine breakthrough? Or is it mostly a political statement? One word in the comments. I will come back to your answers at the end. Let's get into it. Every 6 months, the supercomputing world publishes a list called the Top 500. It ranks the 500 most powerful computers on the planet using a standardized benchmark called LinPack, the same test applied the same way to every machine. No room for creative accounting. On June 23, 2026, at the International Supercomputing Conference in Hamburg, Germany, the 67th edition of that list was released. LineShine debuted directly at #1, not second, not third after a gradual climb. #1, first appearance, beating every machine that has ever been built. Now let me give you the numbers so you actually feel the scale of what that means. 1 exaflop is 1 billion calculations per second. If every single person on Earth did 1 calculation per second by hand, every person, 8 billion people, working simultaneously, it would take them more than 4 years to do what LineShine does in 1 second. LineShine runs at 2.198 exaflops. America's Capitan runs at 1.809 exaflops. That gap is not closed. LineShine beat Capitan by more than 20% on a test that has been the gold standard for measuring these machines for 30 years. And then there is the detail that makes this genuinely different from any previous record. Every Exascale machine that has ever existed, every machine that has ever crossed 1 exaflop used GPUs. Capitan uses 44,500 AMD processors that fuse CPU and GPU technology together on a single chip. America's Frontier machine uses AMD GPU accelerators. Intel's Aurora machine uses Intel GPU accelerators. GPUs are the engine of modern high-performance computing. The entire AI boom runs on them. Nvidia became the most valuable chip company in human history because of them. LineShine has 0 GPUs, none, not 1 accelerator anywhere in the system. Instead, it runs on 13.79 million cores of a domestically designed processor called the LX2, built on the ARM v9 architecture at 1.55 GHz. The machine uses a proprietary Chinese interconnect called LingQi to link everything together, a custom operating system called Kylin and Chinese designed. Storage throughout. Jack Dongarra, the Turing Award winner who co-founded the Top 500 list, said it directly to the South China Morning Post. Quote, "This is the first time a computer with only CPUs has reached Exascale. The man who invented the benchmark just confirmed that what China did is unprecedented." Here is the question every engineer asked immediately when this was announced. How does a CPU-only machine beat GPU-accelerated machines at their own benchmark? Because GPUs are supposed to be the reason supercomputers are fast. They run thousands of calculations simultaneously in parallel. For the kind of massive numerical computation that LinPack tests, GPUs have an enormous native advantage. Choosing CPUs over GPUs for a supercomputer is supposed to be like choosing a sedan over a Formula 1 car for a race. So how did China win? The answer is brute force combined with very clever engineering, and I want to walk you through both. On the brute force side, LineShine does not use better individual processors than Capitan. It uses vastly more of them, 13.79 million cores versus Capitan's 11.3 million. When you cannot win on efficiency, you win on scale. You deploy so many processors, running in such tight coordination that the sheer volume overcomes the perk or disadvantage. But raw numbers alone do not get you there. The harder problem is communication. Think about what happens when you wire together millions of processors. Each one needs to talk to the others constantly. As the system grows, the time those processors spend just waiting for information from each other starts eating into the time they could spend actually computing. It is like adding more workers to a construction site. At some point, they spend more time waiting for materials and instructions than actually building. China's engineers solved this with the LingQi interconnect system, a proprietary network architecture that keeps 13 million cores talking to each other fast enough that the communication overhead does not kill the performance. That is not simple engineering. That is a deep systems architecture achievement that took years of work to get right. And there is one more piece. The LX2 processor has something built into each core called the scalable matrix extension and the scalable vector extension. These are units that handle the specific type of math that LinPack tests matrix and vector operations directly on the CPU without needing a separate GPU to do it. So every single core in the system can handle the benchmark math natively. Put all of that together, 13 million cores, a custom interconnect that keeps them coordinated, and processors with matrix math built in, and you get a #1 supercomputer without a single GPU. Now I'm going to do something that most coverage of this story is not doing. I'm going to tell you exactly where LineShine falls. Short, because this is a complete picture, not a hype video. LineShine is the fastest supercomputer on Earth for the specific type of calculation that LinPack tests that is real, and it is significant. But LinPack is one benchmark, and there is a second benchmark on the top 500 list called HPL-MxP. It tests mixed precision math, the lower precision calculations that AI training actually runs on. This is the number that matters most for the future of artificial intelligence. On HPL-MxP, LineShine placed fourth, not first. Fourth. Capitan scored 16.7 exaflops on HPL-MxP. LineShine scored 7.92. Capitan was more than twice as fast as LineShine on the math that AI training depends on. That gap exists because of the absence of GPUs. When you drop from full precision to the lower precision AI training uses, GPU-accelerated machines multiply their performance. Capitan got a 9.2 times boost. LineShine got 3.6 times. The CPU-only architecture has nowhere to hide when the workload shifts toward AI. There is also a power issue. LineShine consumes 42.2 megawatts to run. Capitan runs on less than 30 megawatts. LineShine is both faster on LinPack and less efficient per calculation. It burns significantly more power to reach its #1 position. So here is the honest framing that the headline version of this story misses. LineShine is the world's best supercomputer for traditional scientific computing, climate modeling, nuclear simulation, materials research, atmospheric physics. These are workloads where it is genuinely first in the world, for AI training the thing that determines who builds the most powerful AI systems, GPU-accelerated machines. Still lead by a significant margin. China did not just build the fastest AI computer in the world. It built the fastest scientific computer in the world, using an architecture that has a meaningful weakness exactly where the AI race is most competitive. That distinction matters. Hold on to it. Here is where the analysis gets genuinely interesting, because understanding what LineShine cannot do actually makes what China accomplished more impressive, not less. Think about why China built a CPU-only machine in the first place. It was not because CPUs are better than GPUs for supercomputing. Every engineer in the world knows GPUs are better for parallel computation. China knows this. China chose CPUs anyway, and the reason tells you everything about the strategic thinking behind this machine. China cannot access Nvidia's best GPUs, cannot access AMD's best accelerators. Export controls placed by the United States block China from importing the hardware that everyone agrees is optimal for this work. So China faced a choice: keep trying to acquire or copy the forbidden chips and remain dependent on whether America decides to let them in, or build a completely independent path to the summit using hardware entirely within China's control. LineShine is that path, proven, benchmarked, verified at #1. Now here's the part that makes this strategically significant, even given LineShine's weakness in AI training math. That weakness is not permanent. It is an engineering problem, and engineering problems get solved. The first time any country built an exascale machine, it was slower than the second time. The second time was slower than the third. China now has a working exascale system built entirely from domestic components. Every chip, every interconnect, every line of software, every cooling system, all of it Chinese. That means China is now accumulating the experience that only comes from running a real system at this scale. They are finding where the bottlenecks are. They are learning what the LX2 processor does well and where it falls short. They are optimizing the LingQi interconnect in production conditions rather than lab conditions. They are building the manufacturing knowledge and the engineering intuition that compound with every iteration. The gap between LineShine's AI training performance and Capitan's AI training performance is real today, but China is now on a learning curve that only exists if you have a machine running, and they have a machine running. Compare this to the alternative. If China had simply kept trying to acquire Western chips, it would be permanently dependent on decisions made in Washington. One export control update and their entire supercomputing roadmap stops. With LineShine, that leash no longer exists. The machine China runs today cannot be switched off by any American policy decision, ever. If you follow Iron Circuit, you know this story has a shape that should feel familiar by now. American export controls blocked China from accessing advanced chip manufacturing machines. China invested in glass substrates, a completely different route to more powerful chips that did not require those machines. American export controls blocked China from accessing the best Nvidia AI chips. China built DeepSeek, an AI model that shocked the industry by matching Western performance at a fraction of the compute cost. American export controls blocked China from accessing the best GPU accelerators for supercomputing. China built LineShine, a CPU-only Exascale machine that just took the #1 spot on the global rankings. Every single time, the shape is the same. A wall goes up. China does not try to climb the wall. China builds a door somewhere else and walks through it. And here is the pattern that should make anyone in Western tech policy think carefully. The capabilities China builds by going around restrictions are capabilities that are fully sovereign, fully domestic, immune to future restriction. The glass substrate technology China built does not need ASML. The AI models China developed do not need American software, and the supercomputer China just proved works does not need a single chip that anyone can restrict. LineShine is not just a supercomputer. It is proof of concept for an entirely independent computing stack. Here is where I give you my honest read on where this goes from here. In the near term, the next 2 to 3 years, America's GPU-accelerated machines still lead on the specific workloads that matter most for training frontier AI models. That lead is real. Capitan is still significantly better at the math AI training runs on. If you are building the next generation of large language models, you still want a GPU cluster, and the best GPU clusters are currently American. But the midterm picture 3 to 7 years from now is where this gets genuinely uncertain. China is now running a fully sovereign Exascale system and accumulating engineering experience on it at speed. The LX2 processor will have a successor. The LingQi interconnect will be optimized. The AI training performance gap will narrow, not because of any dramatic breakthrough, but because that is what happens when serious engineers run a serious machine over time and keep improving it. The question that nobody can answer right now is how fast that narrowing happens. And there is a second variable. China is not only developing CPU-based supercomputing, Huawei's Ascend chips are getting faster. Capitan posted revenue growth of over 4,000% as Chinese companies ordered AI accelerators to replace Nvidia. The GPU-free path of LineShine and the domestic GPU path of Huawei and Capitan are running in parallel. China is hedging across both routes simultaneously. At some point, these paths converge. A future Chinese supercomputer that combines the CPU architecture lessons from LineShine with more mature domestic AI accelerators. That machine would not have the mixed precision weakness LineShine currently shows. That machine does not exist today, but LineShine is the foundation it gets built on. So here is where I land on all of this, and I will give you the honest version, not the comfortable one. LineShine is not proof that China has won the AI race. The mixed precision numbers make that clear. On the specific math that frontier AI training runs on, America's machines still lead significantly. But LineShine is proof that something more important has happened. China has fully closed the door on one form of leverage, the ability to restrict China's access to the hardware needed for world-class computing. That leverage is gone. It cannot be restored by any future export control, because the hardware China needs no longer comes from anywhere America controls. That is the shift, not who has the fastest machine today, who has removed their dependency on the other side's decisions. And here is the thing about removing dependencies. Once you remove one, the next one becomes the priority. China has been doing this systematically across semiconductors, memory, substrates, AI models, and now supercomputing. Each one individually looks like a reaction to a restriction. Together, they look like a strategy. Now I asked you at the start to drop one word in the comments, genuine breakthrough or political statement. I want to see your answers, because my honest read is that the real answer is neither and both, and I think the comment section on this one is going to be genuinely interesting. Here is why your comment matters to me specifically right now. Iron Circuit is building something. Every video covers a different piece of the same larger story, the systematic reconstruction of an independent technology stack, glass substrates, Chinese RAM, DeepSeek, and now LineShine. The next video connects all of these into one complete picture of where this is actually heading over the next decade. If you are not subscribed, you will miss that. And given how fast this story is moving, LineShine just happened 3 days ago. Missing even one piece means the next piece makes less sense. Hit subscribe, turn on notifications, and drop your one word in the comments right now. I read every single one, and I will see you in the next video.